Welcome everyone. We're going to try things a little different now with this unit. I'll try to make some small little kind of mini note lessons, and then you can go through and follow along, and then I'll give you some practice to go along with it with like a little quiz at the end of the week for kind of the subsection. So here's the first attempt at it. So we're going to be going into a unit on heat and thermodynamics. There's going to be some overlap with what we did in chemistry, as well as this a little bit. So some of this will be a little bit familiar, but today is really just starting with the basics of temperature and what temperature is. So when we talk about temperature, our definition of temperature is really just this idea it's an average kinetic energy of atoms or molecules. So the idea is the faster the molecules are moving, this goes back to the kinetic molecular theory, the faster the molecules are moving, the more kinetic energy they have, thus they have a higher temperature. And we had that little plastic bottle with the stoppers, the cork in there, and we shake it and just kind of show that in chemistry along the way. So that's kind of what we're talking about. Now, when we talk about what scales do we measure temperature in, here in the United States, we use degrees Fahrenheit. And that's what we've kind of always grown up with, and it's what we're used to. Most of the rest of the world, however, does not use degrees Fahrenheit, and the idea is we should be able to convert back and forth between these. So degrees Fahrenheit and degrees Celsius, those are the things that we're going to be able to kind of convert between. So that's kind of everyday stuff that we use is degrees Celsius and degrees Fahrenheit. In the rest of the world, they use Celsius. So we'll go through and we'll expect you to be able to make those conversions. And then the other one that we use in science a lot is Kelvin, degrees Kelvin. And we just simply use the letter K, but this represents like degrees Kelvin. So there's no degrees symbol. Notice how these have a degrees symbol, but there's no degree symbol there. That's because we just don't do it, but it is technically still 22 degrees Kelvin. We just don't write the symbol. So our formula for it is slightly different than you've probably used in the past. You've often used like a fraction of 9/5 or 5/9, and depending on which way you go, depends upon is it 9/5 or 5/8. But when we go through, we just use a single equation and we can modify it to fit it and solve for whichever variable we want. So TF, so this is going to be our temp in degrees Fahrenheit. So our TF is equal to the number of 1.8 times our TC, which is going to be our temp in degrees Celsius. That's going to be plus 32. So depending upon what's given, are you given degrees Fahrenheit or are you given degrees Celsius, depends upon... Sorry, my furnace fan just kicked on and I had to close the door. So depending upon which variable you're given, depends upon where you're going to plug that number in. So if you're given like 10 degrees Celsius, you put a 10 here and you go, remember order of operations, you do your multiplication first, then you do your addition to get your degrees Fahrenheit. Now, if we were to go the other way, in order to give you 10 degrees Fahrenheit, then we have to do our subtraction. We have to subtract 32 to the other side, and then we'll do our division. So that's our formula that we're going to use for Fahrenheit to Celsius or Celsius to Fahrenheit. The other one that we use is this equation for TK. So TK stands for temperature in Kelvin, and that TK is simply taking our TC, our temperature in Celsius, and we add 273.15 to it. Now, Kelvin is an absolute temperature scale. At 0 Kelvin, 0 Kelvin is what we call absolute zero. And absolute zero is this theoretical point where all molecules stop. So if our average kinetic energy of an atom is temperature at 0 degrees Kelvin, we are saying they have zero kinetic energy is essentially what we're saying, and all molecules have actually just stopped moving at that point. So some pretty common temperature conversions, or pretty common temperatures that we kind of use, and is just kind of something I kind of expect you to know along the way, is some of these freezing and boiling points. So freezing point, remember, freezing point and melting point are really one and the same, as whether we're adding heat or removing heat. So if we're removing heat, like the Lake Wassa freezes at 32 degrees as it gets colder, but Lake Wassa melts at 32 degrees as it warms up. So it's just depending upon which direction we add heat. So the freezing point in degrees Fahrenheit is 32. That's our freezing point, our melting point. Our boiling point is 212 degrees, which gives us a difference of 180 degrees Fahrenheit. And I'll talk about why we even care about this in just a little bit. So that's kind of everyday stuff. That's stuff you probably know. The next thing that we're going to talk about is in Celsius. Now, you've been in science classes for many, many, many years, so I'm guessing at this point you know these as well, that water freezes at 0 degrees Celsius and it boils at 100 degrees Celsius, and the difference between those is, of course, then 100 degrees. Now, if we are looking at these differences, what we have to do whenever we talk about a change in temperature, we have to have it in the scales that we want first, and then do that. So remember, when we talk about like a change in temperature, what we're saying is my final temperature minus my initial temperature. So if it starts at 20 degrees in the morning, but it ends at 50 degrees, my final temperature was 50. 50 minus 10 would give me a positive 40. Compared to if we started at 50 and we end at 10, then we would have a negative 40, right? It cooled off during the day. So if we then use this equation to go through and talk about these temperature points in Kelvin instead of Celsius, we have our Celsius. All we have to do is add 273.15. So 0 plus 273.15 is 273.15. That's the freezing point of water in Kelvin. If you take 100 times, adding, that's a 273.15. The boiling point of water is 373.15. But once again, this difference is 100 degrees difference. Okay, so we'll go through a couple quick calculations here to kind of go through and kind of practice this. So if we talk about body temperature, we often say that a normal body temperature is 98.6. Now realize that it varies some from person to person. Some people are a little bit warmer, some people a little bit colder. But that's what we often consider to be a normal body temperature. So if this is in degrees Fahrenheit, and we say, well, how many degrees Celsius is that? We're going to use the equation to go from TF to TC. So we can then go through and say, well, my TF is equal to 1.8. Let's start plugging. I don't have enough space. So we're going to use this equation. I'm going to plug my numbers in directly. So we can say my TF is the 98.6 is equal to 1.8 times TC plus 32. Then what we can do is we can just do the algebra. Now, this is a multiplication. This is the addition. So the first thing we're going to have to do is take this number, and we're going to have to subtract 32 from both sides. So we're going to move this 32 over. We're going to subtract 32. And then after we do the subtraction, then we're going to divide by 1.8. And once we do that, we go through and we plug it in our calculator, and you should get 37 degrees Celsius is our body temperature in Celsius. So, if you went to another country and they took your temperature because you were in the hospital, you should be right around 37 degrees. Now, just to kind of do a couple more conversions, if we say you have a slight fever, then we're going to say your body temperature is 38 degrees Celsius, not 37 degrees. So it's 1 degree warmer. You say, well, is 1 degree warmer a lot? Is it not a lot? Well, let's calculate that. So we're going to now, what we want to do is we want to know how many degrees Fahrenheit is that. So my TF is what we're solving for, is equal to 1.8 times 38, and that's going to be plus our 32. So multiplication, order of operations, we do our multiplication first, then we do our addition, and then when we do that, we come up with a final answer. My temperature in Fahrenheit is 100.4 degrees Fahrenheit. So that's often what they consider. If you have a slight fever, they say you have a temperature of right around 100.4. Now, a little bit more, a little bit less. At most point, no one is too concerned about a slight fever most of the time. Now, when you get something called what they sometimes consider a severe fever, now you have a temperature of like upwards of 103 degrees Fahrenheit. So if we were going to then say, well, what's our TC? So TF, so we're still just using this equation right here. So my TF is 103 is equal to 1.8 times TC plus 32. So now, order of operations, we have to do our subtraction. We have to subtract 32 to this side. Then we're going to divide by 1.8. And our temperature, our degrees in Celsius, are 39.4 degrees Celsius. Okay, so that's how we can just use this equation to go through. And this is just an example. So now they often talk about symptoms of COVID-19 is you have a fever. I'll be honest, I'm not sure if they're talking severe fever, slight fever. I'm not really sure, but that's when they're talking about fevers, we're talking like right around the 100 plus number, right? 100 to 103 is what we consider like a fever typically. So one more problem that we'll do together with you, I'll kind of walk you through it, and then I'm going to tell you to hit pause and then try this one on your own and then unpause it, and then we'll walk through it one last time. So, oh, I'm sorry about this. I forgot this. I had a mistake. This is supposed to be in Celsius. I'll make that change on the PDF that you have in front of you, so this should be good. But the coldest temperature in Wausau, according to some quick internet search that I did, was negative 38 degrees Fahrenheit in 1886. Did we beat that last year or the year before? I'm not really sure. That's what popped up, so that's what I'm going with. So if we have a temperature of negative 38 degrees Fahrenheit, what is our temperature in Celsius? And then what's our temperature in Kelvin? Okay, so we're going to be using these two equations to solve that. So go ahead and hit pause when you're done. Unpause it, and we'll work through these together. All right, now that you work through those on your own, let's kind of walk through it together. So the first thing we got to recognize that this is this is my TF, right? That's my temperature in Fahrenheit. So TF is equal to 1.8 times TC plus 32. And we're trying to determine my temperature in Celsius. So my TF is negative 38, which is equal to 1.8 times TC plus 32. Now, again, order of operations, we have a multiplication here, but we want to move this, before we do the division of the 1.8, we have to move that 32 to the other side. So we have to subtract 32. So when we subtract 32 from both sides, this is a negative number, so it's negative 38 minus 32. And then when we're going to do, then we'll go through, and then we have to do our division of that. So when we take negative 38 and we subtract it we subtract 32, we get negative 70 is equal to 1.8 times TC, divide both sides by 1.8, and our TC ends up being negative 38.8888 degrees Celsius. Now, if you notice, these are really close. There's like negative 40 is kind of the number that they often say, like negative 40 degrees Fahrenheit and negative 40 degrees Celsius are about the same. So it just happened to be that these are really, really close. The last part is, what's your temperature in Kelvin? Now, whenever you ask they ask us to solve for Kelvin. Notice our formula is Kelvin and Celsius. It's not Kelvin and Fahrenheit. So if we are solving for temperature in Kelvin, we have to get to Celsius first. Okay, so we can't go straight from Fahrenheit to Celsius using the equations we have. Now, is there another equation out there? I'm sure there is that goes straight there, but that's not what I have. So now that we know what my temperature in Kelvin is, we can say, or Celsius, I'm sorry, my temperature in Kelvin is equal to Tc plus 273.15. My temperature in Kelvin is equal to negative 38.899 or 8888888, right? Keep as many decimals as we can here. Do as little rounding as possible. And then when we take that number and we go through and we take negative 38.89 and we add it to 273.15, we get a temperature in Kelvin of 198.26 Kelvin. Okay, so that's just how we do this. So now what I'm going to ask you to do is, now that you've done with that, now I want you to go into modules on Canvas. There's a worksheet in there called Temperature Conversion Worksheet. It's a PDF. You guys probably know how to do this better than I do, but you should be able to open that PDF in like Notability, and you can mark it up on there, or you can use your markup tools right from your probably camera roll. You could take screenshots if you want. That's really up to you on how you do it, or simply just take a piece of scratch paper and work those through problems 3. Okay, there's like 4 sets, and I'm going to say skip question number 4, and it's like an A, B, C, and I did a strike through on them. And then all of the answers are found on page 2. As you're working through these, if you have any questions, please pop into office hours and ask questions on this stuff. It's really just plugging in and keeping track of your algebra along the way. If you have any questions, let me know. There is a quiz that you need to finish for the end of the week that is on unit temperature conversion and temperature conversion alone. If you have any questions, let me know. Thanks.